The field of paleontology has just been shaken by a discovery that challenges our visual perception of the giants that inhabited the Earth millions of years ago. Recently, researchers identified a new species of herbivorous dinosaur with a defensive characteristic never before documented in its group, making it look more like a giant porcupine than a conventional reptile. This fascinating creature, which lived about 125 million years ago, possessed a body covering composed of hollow spines embedded directly into its skin. Unlike the heavy bony armor we usually see in ankylosaurs, this new specimen presented an innovative and lightweight biological strategy, revealing that the evolutionary diversity of these animals was even more complex than previously imagined. The fossilized remains were located in China by an international team led by the CNRS and collaborating institutions, revealing a young dinosaur from the iguanodontian group in an absolutely surprising state of preservation. The specimen received the scientific name Haolong dongi, a fitting tribute to the renowned Chinese paleontologist Dong Zhiming. What makes this find so special is not only the articulated skeleton, but the fact that the animal's skin has withstood the passage of time for 125 million years. Finding soft tissue fossils is extremely rare in science, and this specimen stands out as a direct window to the past, allowing scientists to analyze biological structures that normally disappear completely in the traditional fossilization process. The preservation of this dinosaur is so exceptional that it allowed scientists to observe microscopic details that are usually lost forever. Through the use of advanced technologies, such as X-ray computed tomography and ultra-high-resolution histological analyses, the research team was able to identify individual skin cells of the animal dating from the lower Cretaceous period. This is a historical milestone, as it allows us to see beyond the bone structure and understand the cellular biology of an organism that ceased to exist long before the emergence of our species. This wealth of detail has transformed Haolong dongi into one of the most important soft tissue fossils ever studied by modern science, offering unprecedented data on the dermis of dinosaurs. Thanks to this microscopic level of preservation, experts were able to accurately reconstruct the structure of the spines that covered much of the dinosaur's body. The most fascinating finding revealed by the histological analysis is that these projections were not solid extensions of the skeleton or fused bony plates, as seen in many other armored dinosaurs. Instead, they were completely hollow cutaneous structures, an anatomical feature entirely unprecedented in the world's dinosaur fossil record. This discovery redefines what we know about the dermal covering capabilities of these animals, showing that evolution tested very specific biological pathways to ensure the protection and survival of these herbivorous species. Analyzing the ecological context in which Haolong dongi lived, it becomes clear that it inhabited vibrant but dangerous ecosystems, teeming with small carnivorous dinosaurs constantly hunting. Faced with this selective pressure, the defensive hypothesis for the spines gains immediate strength. They would have functioned as a formidable physical barrier against voracious predators. Similar to modern porcupines, Haolong likely made any attempt to bite or attack an extremely painful and discouraging experience for predators. This external protection would have been crucial for a young and relatively vulnerable herbivore, ensuring it could feed without becoming easy prey in an environment dominated by fast and opportunistic predators. However, science is never limited to just one explanation, and researchers raise other intriguing possibilities for the function of these spines. Structures that dramatically increase the surface area of the skin, such as these hollow projections, may have played a vital role in the dinosaur's thermoregulation. In a world of variable climates, these spines could have helped the animal release excess body heat or even conserve thermal energy as needed by the environment. Furthermore, there is a chance that these projections had a keen sensory function, allowing the dinosaur to detect vibrations, subtle movements in the air, or drastic changes in temperature and humidity around it, functioning almost like antennas distributed throughout its body. A crucial detail that still generates debate and curiosity is the fact that the fossil belongs to a young individual. In biology, many physical characteristics change drastically as an animal matures and develops towards adulthood. Therefore, scientists cannot yet say with complete certainty whether adults of the species maintained this exuberant spiny covering or whether the spines were a temporary characteristic of youth to ensure protection during the most critical and fragile phase of life. New discoveries of specimens at different stages of growth will be necessary to answer whether Haolong dongi maintained its exotic appearance throughout its existence, or whether it underwent a morphological transformation upon reaching maturity. This fascinating study was recently published in the prestigious journal Nature Ecology and Evolution, and introduces a completely new morphological characteristic to the dinosaur family tree. The Iguanodontia group, which has been studied by paleontologists for over 2 centuries and includes some of the most classic fossils in history, has proven to be much more varied, innovative, and visually rich than anyone could have originally predicted. The impact of this discovery is enormous, as it forces scientists and illustrators to reconsider how we visually represent these animals, suggesting that many other known dinosaurs may have had bizarre appearances and skin structures that we are not yet aware of due to lack of preservation. In conclusion, Haolong dongi represents much more than just a new name on a list of extinct species. It is living, or rather fossilized, proof that nature still holds spectacular surprises hidden beneath layers of sediment millions of years old. Through this discovery, we understand that dinosaur skin, something that rarely withstands the erosion of time, can hide biological secrets as fascinating as their colossal skulls and teeth. As imaging and analysis technology advances, we get closer and closer to seeing the prehistoric world with the clarity of someone observing a photograph, revealing that the reality of evolution on Earth was far more complex and creative than our best science fiction films.